Hello and welcome to a video about Group 1 elements. Group 1 is also known as the alkali metals. We know that they're metals because they're on the left-hand side of the periodic table, and these alkali metals are found in the first column of the periodic table. All Group 1 metals have one electron in their outer shell. This means that when they react, they need to lose this electron so that they now have a full outer shell of electrons and that they're stable. By losing an electron, they become +1 ions. This is because electrons have a negative charge, and so if they lose an electron, they'll now have more protons than electrons, and so the overall charge will be positive. The alkali metals all have similar properties. They have low densities, which is quite an unusual property of metals, which means that they can float on water. They're also quite soft and can be cut with a knife. As most metals are, Group 1 metals are shiny, but only when they've been recently cut, because they react really quickly with the oxygen in the air, which quickly tarnishes them into a white or dark, dull colour. The Group 1 metals are also very reactive, and the reactivity of the metals increases as you go down the group. In the exam, they might ask you to explain why the metals get more reactive as you go down the periodic table. If you can do this, this will get you the highest possible marks. As we said before, when Group 1 metals react, they lose their outer electron. If you have a look at these electron structure diagrams, you can see that as you go down the group, the electron that's being lost is always in the outer shell, but the outer shell is much further away from the nucleus in the centre. The nucleus is the positive charge, and that's what is attracting the electrons towards the centre. So the further away the electron that's being removed is from the nucleus, the easier it is to remove the electron, because the nucleus attracts it less strongly. Group 1 metals react with oxygen. For the exam, you may be expected to write a chemical equation for this reaction, which could be in word or symbol form. In this example, this grey circle represents a Group 1 metal. Let's say lithium. If you look on the periodic table, the symbol for lithium is Li, remembering the capital at the front, the small letter at the second. Then this molecule that we've got is oxygen. As you'll see later on, it's common for non-metals to exist as molecules like this. Oxygen is O2. So when they react, they combine together to form lithium oxide, which is Li2O. This formula means that there are 2 atoms of lithium for every 1 atom of oxygen. We'll discuss in more detail later on why this formula is like this, but for now, just think of it as the idea that each lithium atom has a positive charge, each oxygen atom has a -2 charge, and because all compounds have to have a neutral charge, we need 2 positive charges to balance out the 2 negative charges of the oxygen. Therefore, lithium oxide is Li2O. However, if you look at the diagram, you can see that on the left-hand side there's only 1 atom of lithium and there are 2 atoms of oxygen, whereas on the right-hand side we don't have the same number of each. Again, we'll talk about this in more detail later, but it's important that the equations are balanced so that we have the same number of atoms of each element on the left-hand side and the right-hand side of the equation. So we need to balance the equation by adding another molecule of lithium oxide, making 4 lithiums on the right and 2 oxygens. And now on the left-hand side, we need 3 more lithiums, so now there are 4 lithiums either side and 2 oxygens either side. This is balanced. This will then help us to balance the symbol equation, making 4 lithiums, 1 oxygen molecule which contains 2 oxygen atoms joined together, and 2 lithium oxide molecules, which together mean we have 2 times 2 lithiums and 2 times oxygen atoms. So in the exam, you could be expected to describe the observations you would see when lithium or any of the group 1 metals react with oxygen. At room temperature, they react with oxygen in the air to form a white metal oxide that coats the outside of the metal. But if heated, then they burn vigorously, releasing a lot of heat and light, as well as forming a white smoke, which is the metal oxide. It's also worth noting that group 1 metal oxides are readily soluble in water to form colourless solutions, which are alkaline, otherwise known as metal hydroxides, and this is where the name alkali metals comes from. Other reactions that group 1 metals do include reactions with chlorine and other halogens. Again, in this diagram, this grey circle represents the group 1 metal. This time, let's say it's sodium. Sodium is Na on the periodic table. We're reacting it with chlorine. Like oxygen, chlorine is also a molecule that contains 2 atoms joined together, so we write it as Cl, the symbol for chlorine, and a little 2 to show that each molecule contains 2 atoms of chlorine joined together. When they react, they form a metal chloride, and in this case, it's sodium chloride. As sodium is in group 1, it forms a +1 ion, and because chlorine is in group 7, it forms a 1- ion. So the formula for sodium chloride is NaCl, just one of each. Now we've got to look back at the balancing. Because there is 1 sodium on the left and 2 chlorines on the left, but we had 1 of each on the right, we needed to add another molecule of sodium chloride so that we had the 2 chlorines that we started with. But now we have 2 sodiums, so we need to add another one onto the left-hand side. This means that in our balanced equation, we have 2 sodiums, 1 chlorine, and 2 sodium chloride molecules. These would be the balanced equations for all 3 of the group 1 metals. Have a look and see that all of the equations have exactly the same structure. The metal times 2 reacts with the molecule of chlorine to make 2 of the compound lithium chloride, sodium chloride, or potassium chloride. Again, it's worth noting what you would see, the observations in this reaction. As we said, group 1 metals are very reactive, so the reaction would be very vigorous. This means you would normally see a lot of bright light and lots of heat produced. The product is a metal chloride, which is a white solid, otherwise known as salt. Sodium chloride is the chemical name for ordinary table salt, but even lithium chloride and potassium chloride are white solids that we can call salts. These salts dissolve easily in water to make colourless solutions. All group 1 metals react in this way with chlorine, as well as with the other halogens, fluorine, bromine, and iodine. Finally, you need to know about how group 1 metals react with water, and this is probably the most famous of the group 1 reactions. It's likely that in class you'll have seen a demonstration of group 1 metals reacting with water. Again, these are very vigorous reactions. You'll see fizzing or bubbles, or you may want to call the same thing effervescence. The metal floats on the water and moves around the surface of it. Eventually, the metal dissolves, and the remaining solution is alkaline. In the case of potassium, because it's further down the periodic table, it's more reactive. It melts into a ball and then actually bursts into flame, which has a distinctive lilac colour. Let's have a look at the equation. This time let's use potassium as an example. And remember, we're reacting it with water. Potassium is K on the periodic table and water is H2O. When they react, they form a metal hydroxide, so in this case potassium hydroxide, and hydrogen gas. Potassium hydroxide has the formula KOH. K for potassium, which is a +1 ion, and OH for hydroxide, which together is a -1 ion. So the positive and the negative cancel out, and we have KOH. Hydrogen gas, like oxygen and chlorine, exists as a molecule that has two hydrogen atoms joined together, so the formula for it is H2. To balance it, we need an extra water on the left-hand side, an extra potassium hydroxide, and an extra potassium. So this gives us 2K, 2H2O, 2KOH, and 1H2. If you look at each of the diagrams, you can see now that there are the same number of potassiums on the left and right, the same number of oxygens, the blue ones, and the same number of hydrogens, the red ones. As with the other reactions, the equations are the same for all the group 1 metals, exactly the same pattern with the same balancing, because they have the same number of electrons in their outer shell. This concludes our video about group 1 metals. The main keywords we've covered today are listed below. See you again soon on another video by mygcsescience.com.